Hello again, class. This is Scott. We're going to take a look at section 2.5 today. 2.5, there's a lot of information in there, and we're going to kind of look at the U.S. customary system of measurement. And section 2.5 begins on page 101. I'm just going to kind of talk about some different pieces throughout this and kind of not exactly follow exactly what the way they approach it in the book with that too. And so there you can use their information and examples too along the way. One thing that you'll probably want to make note of too is there's a chart on page 105 that talks about conversion factors. That will be beneficial as you go along with that. And there might be a couple that you might need to just kind of figure out on your own too with some of those things there. We'll look up and we'll talk about too with all that. So, but anyway, the first thing it kind of talks about here is it says about converting fractions to different types of, converting some measurement to a different type of unit. For example, it has 4 feet. It talks about 4 feet, and you want to know how many inches that is. Okay. Well, it talks about using ratios, proportions, things like that to do that. I've always kind of taken it a different approach here with that too. Now, by the way, that's not 7 inches. That's a question mark there, just so you know. Okay. So if you've got 4 feet and you want to know how many inches that is, okay, how many inches are in a foot? What can I do to go from feet to inches that way? And I know there's 12 inches in 1 foot. Now, the cool thing here, 12 inches, 1 foot. Since there's an equal sign there, that really means that they're the same. Okay? They're the same thing. So just like 3 equals 3, they're the same thing. Okay, so if I took 3 over 3 in a fraction, really that's the same thing as 1. Well, if I took and put 12 inches over 1 foot in a fraction, it's the same thing as 1 also, because they're the same. I could reduce that down and get 1. And that's what we're going to want to use here to convert feet to inches. And then it's just a multiplication problem then. So what I do is I know that 12 inches is 1 foot. I know I need to put inches in the numerator because that's what I want to get to in the end. And I also want my labels of feet to reduce out, just like we did with the fractions before, as we were multiplying fractions. And so what I have here now is I have my feet here, which I can reduce with that feet. I have my label of inches left over, and now really it's just multiplying fractions now. 4 times 12 is 48. We have our label of inches, and then 1 times 1 is 1, so I really don't need the 1 anymore. So your answer is 48 inches. Okay, you can convert anything that way. You just need to be patient and make it through there with all that. So let's do a bit of a crazy one with all that. And I'm going to do a bigger sheet of paper because that's just not enough room left here. Let's say we're gonna you're looking at doing something on the interstate, and you're on the interstate. You know that you can go 75. You can, even if your pen doesn't work, you can go 75 miles per hour, and you want to know how many feet per second is that. And 75 miles per hour. How many feet per second is that? So, what we would want to do, first of all, per hour, really that means it's a division problem. So this is really 75 miles per 1 hour. Okay, that's what that would look like. And so you want to still know how many feet per second that is. All right. So what we have to do then is we have to convert miles per hour to feet per second. So I'm going to have to write a little bit smaller here. I have 75 miles per 1 hour. Well, first of all, let's go ahead and convert miles to feet. Let's start with one of those things. So I know that there is 5,280 feet in 1 mile. There's 5,280 feet equals 1 mile. So if I set that up as a fraction, I could put 5,280 feet over 1 mile. And so that's the same as 1, so I can put that right up in here. And so I've got 5,280 feet over 1 mile. So, okay, so now I can go ahead and do that. I can already got this, and that's cancel off. So I got my answer in feet per hour, feet per hour. Okay, so I need it feet per second, though. So, okay, what do I need to do then? Whoops. What do I need to do then? Okay, so I know that there is 60 minutes in 1 hour. So I can go ahead and say, okay, 1 hour, 60 minutes. Now notice what I've done with this fraction here. I have the hour up top. The reason is I need my hours on the opposite side so they can reduce out. I can cancel them right here. And math teachers hate to use the word cancel with that because you aren't canceling anything. You're just, it's being eliminated or it's reduced. But every once in a while I'll say cancel. So I apologize. So now we have our answer in feet per minute. So now if we want it feet per second, well, I go, I know there is 60 seconds in 1 minute. So once again, my conversion would look something like 1 minute over 60 seconds. And 1 minute over 60 seconds. And now my minutes cancel off. So I am left with my answers now of feet per second. So that's kind of cool. And then what I have to multiply is 75 times 5,280 times 1 times 1. And in the denominator, I need to take 1 times 60 times 60. That was just fun using the colors. All right. So as I do that, if I take 75 times 5,280, okay, as I do that, 5 times 0, 0. I'm running out of room. Okay, can you guys trust me on this if I just multiply it out? Okay, so 5,280 times 75 equals, holy, help me, Hannah. We have 396,000 feet, and I know 60 times 60 is 3,600 seconds. Okay, so once again, we got to reduce that down. I don't know if we're lucky enough to have 3,600 to go into 396,000 evenly, but I am going to try. Whew, and it does. It does go there. It's 110. It goes, oops, that's a bad 110 even by my standards. 110 feet per second. Cool. Cool. So that would be our answer then with this. 110 feet per second. And you would have that all converted out that way. Now, the other thing you could have done here is you could have had reduced this down or, as you went along here. Because you could have said, well, all right, 75 and 60, I know 15 goes into each of those. So I could take 75 and make that 5, make this 4. And then reduce 5,280 here with the 4 and the 60 and gotten down to this exact same thing. So you would have ended up with 110 right there. I chose to multiply it out a little bit because those are some big numbers to try and reduce down, and I just wanted to work with it at the end. But you can see kind of what you have to do here is it's just a step-by-step process to take you from one point to the other, and you have to look at each little step along the way, not, oh my gosh, how am I going to get from miles per hour to feet per second? Just first of all, you got to get miles to feet, and you got to get hours to second. Both things that you can do, and it takes you along the way that way. So, the other thing that kind of comes into play in this unit too, and it's something that we do in our lives all the time with addition and subtraction, but when you aren't working with base 10 numbers, when you aren't working with those types of things, it becomes like, oh yeah, I got to do that too. What I'm talking about here is let's say we're going to add 30 minutes plus 45 minutes. Okay, so I take 30 plus 45 and I get an answer 75 minutes. However, this is very similar to an improper fraction, because really isn't there another unit that would be larger than, or that would work here in the 75 minutes pieces? Yeah, there is. There's the hour. So really, you've got to take out 60 for every 60 minutes. You have to take out and make it an hour. Okay, so really, as you go to carry numbers, you're working in something that's that has the total part of it is 60 and not 10 or 100. And so after every 60, you have to, think of it this way. We've got buckets here. Okay. Normally we put in ones here all the time. 1, 2, 6, 7, 8, 9, 10. Okay, that bucket of 10s is full. Okay, so now I have 10 here. Now I got to start putting ones in this one over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that bucket of 10s is full. I need a new bucket of 10s. And so every time we fill up a bucket of 10s, those keep disappearing on me over there. I don't know how that happens. We get another bucket. Okay, when you're working with minutes here, okay, our bucket goes up to 60 minutes. So if I put in 30 minutes and I want to put in another 45 minutes, really, I've only got room for another 30 minutes in here. So I put in that next 30 minutes, and then I've got to put 15 minutes in this next bucket. So really, I don't have 60 minutes here. I have an hour and 15 minutes. Okay, because my bucket of minutes is full once I get to 60. Not 10s like we're used to and just carrying and going as if everything is hunky-dory. But my bucket is full here with 60. Same thing would be true with like ounces in a pound. Let's get us another page here. Okay. Let's say you've got 20 ounces, and you're going to add to it another 50 ounces. Okay, and so together those make 70 ounces, but there's pounds in there, and there's 16 ounces in a pound. So I know how many pounds an ounce it is, just not how many ounces it is. So if we keep that same bucket idea, well, for 20, I've got 16 ounces in there, because that's what my pound is. And then I've got 4 from here. That gives me the rest of my 20. Well, now for 1 pound here, I got room for 12 more ounces. So 50 minus 12 gives me 38. So I got my other 12 ounces here. And now minus 16 gives me 22. Okay, so I got another 16 in there. 22 minus 16 is going to give me 6. So I got another 16 ounces here, pound, and then I've got 6 ounces in this last one. So what I have really is 4 pounds and 6 ounces. And you could do the same thing here too, as if you took 70. I know there's 16 ounces in a pound. Put 16 here. I wonder how many times that goes in there. Oh, 4, that's right. 4 times 4 is 24. Carry 2. Whoops, not 60. Got a little zealous there. Okay. Then I got a remainder of 6. So I still have my 4 pounds and 6 ounces. Okay. That's going to be your standard notation, because if you saw something as 70 ounces, that's not correct in standard notation, and it's going to ask you to convert some of those things in your book. It's just like if you had 3 pounds and 22 ounces. 3 pounds, 22 ounces. Not standard notation, not the way you would expect to see things that way. So that's kind of the gist of the working with the measurements piece. Big thing is you're going to have to be able to convert. You're going to have to add and subtract, borrow with all these things too. Same thing would be true here as if I was going to subtract something here too. Let's work on one of those problems real quick too. I'll put another page in here. La 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 la. Feet and inches is another good one. Okay, let's say I've got. We're gonna try and figure out how much taller I am than my daughter. Well, let's go with that one. And we're also, since some of you know me, so I can't lie a lot about my height, but I'm going to change it just a little bit to make it a problem more fun. Okay, so let's say before osteoporosis and everything, I was 6 feet 2 inches tall. Okay, and my daughter is 4 feet 10 inches tall. And I want to figure out how much taller I am than my daughter. Now, once again, that's a subtraction problem. Okay, and it'd be a lot easier if I was 5'11", then we could just subtract that way. But I have to take 10 inches from 2 inches. Yeah, not possible. Okay, so I have to borrow, just like before. If in a normal math problem, if you had like 62 minus 49, you have to borrow. Okay, I borrow, bring that over here. Well, you're borrowing a group of 10 because there's 10 ones in this 10 piece here, and that's what you're borrowing to bring over here to subtract. You get your answer 13. Well, over here, you're borrowing 10 inches because there's 12 inches in a foot. So when I borrow a foot, okay, I'm borrowing 12 inches, so I have to add 12 onto this too. So this gives me 14 inches here, not 12 inches. And you just got to keep that in mind as you're working with these pieces. It's not customary units of measurement. It's you have to borrow what it's worth. If you're borrowing from a pound, you're borrowing 16 ounces. If you're borrowing from a yard, you're borrowing 3 feet. If you're borrowing from a quart, you're borrowing pints. 4 quarts, pints, 16, 2 pints. Thank you. Sorry, little brain fade there. But anyway, so I go to subtract. I go to subtract now 4 inches, okay, and 1 foot. So at this point in time, in theory, I am 1 foot 4 inches taller than my daughter. So those are some of the pieces too that you need to work with all that too. They're going to have you multiply and divide with these pieces also, and then you just have to once again rearrange them to get them back to customary format with all that. So let's say I've got 2 pieces of pipe that are 2 foot 10 inches long, okay, and I want to know how much total pipe I have, so I have to take that times 2. So, well, 2 times 10 is 20 inches, and 2 times 2 is 4 feet. Well, that's great, but I can't leave it like this because you don't want to leave it as 20 inches. So you have to go ahead and you didn't carry before because it's you're working with some kind of different stuff here, but you know that there's 12 inches in a foot. So if I subtract 12 inches out of here, I get 8 inches, and then I have to add 1 foot over here. So I have 5 foot 8 inches of pipe. That works good that way. Then you're going to have to divide some of those things out that exact same way as you go through that too. So for hours and days and things like that. So I'm running out of room. Let me put another page in here real quick. Let's say you're going to have let's say you're going to have 2 days and 4 hours, and you're going to spend half your time sleeping and half your time running errands, for lack of a better thing to do here. So you're going to divide it by 2. So you take the 2 in each one here. So 2 days divided by 2 is 1 day, and 2 days divided by 4 hours is 2 hours, and that would be your answer. But now you might have to, something crazy might happen here. Let's do that. Let's make something crazy happen. Let's make this 3 days and 4 hours. So if you have 3 days and 4 hours divided by 2. So given that fact, now I take 2 divided by 3, I get 1.5 days and 2 hours again. That's all well and dandy, but I'm not going to accept the answer of 1.5 days, 2 hours. So you have to go ahead and get rid of that decimal out of there. So you're going, oh, what do I need to do there? Well, in a day, there is 12 hours. So really, this is 1 day and 12 hours. This is really 1 day and 12 hours. And I got another 2 hours here. So it's 1 day and 14 hours. So you just gotta kind of walk through them a little bit and make sure your answer sounds right at the end. You know, when you see an answer like this, go, oh, you can't just go, oh, that's why I'm done. No, you aren't done, because you need to make sure that it makes sense too with some of those things. So that's kind of section 2.5. The problems on that begin on page 113. And it will go from 1 through 90. Once again, these problems are meant to help you understand the material more. You know, you can do as many or few of them as you would like, and we can go from there with that. So this is the last section in Unit 2. This will prepare you for the review exercises and eventually the test with all that too. So thank you. Have a great day. Bye.